So at module 3, it says determine the value of k for which the function, determine the value of k for which the function is continuous for all values of x. All right, to determine when the function is continuous, that means we're going to apply limits. So the function is continuous if the limit from both sides are equal. So the limit as x approaches 1 of x to the 5 minus 1 over x minus 1, that should be equal to the limit as x approaches 1 of k, because the limit should be equal on both sides. Now the limit as x approaches 1 of k is just k. That's just going to be k. But now we have to remember a formula, x to the 5th minus 1. Write it better. X to the 5th minus 1, there's a formula for that. A to the n minus b to the n. All right, so we have to apply that formula and say this is now the limit as x approaches 1 of a to the n minus b to the n is equal to a minus b. So it's going to be x minus 1 times a to the n minus 1, which is x to the 4. So it's x to the 4 plus x cubed times 1 plus x squared times 1 squared, which is plus x squared, plus x plus 1 over x minus 1. So then the x minus 1 cancel the x minus 1, and then we'll plug in x equal to 1, and so now we get 1 plus 1 plus 1 plus 1 plus 1. So we get 1 plus 1 plus 1 plus 1 plus 1. And so we get that is what k is. So k is 5. Therefore, k equal 5. Easy question, soft. Nice. K equal 5. Nice. All right, part B. Part B says a curve is described parametrically by the equations x equal 5t plus 3, y equal t cubed minus t squared plus t. Find dy by dx in terms of t. So the curve is defined parametrically. We need to find dy by dx. So this is x and this is y. So we just have to remember that dy by dx is equal to dy by dt times dt dx. Dy by dt times dt dx. That's dy by dx. And so dy by dt is, we differentiate this. Dy by dt is going to be 3t squared. Now let's find the differential of minus t squared is minus 2t. That's minus 2t. So that's dy by dt times dt dx, which is divided by dx dt. Dx dt, when you differentiate dx dt, you just get 5. So that's dy by dx. Nice and easy. So that's dy by dx. No sugar to this question. 3t squared minus 2t over 5. Nice. It says, hence, determine all points of C such that dy by dx equals 0. So this is dy by dx. We're going to solve it equals 0. So we're going to be solving 3t squared we're going to be solving 3t squared minus 3t squared minus 2t over 5. That was dy by dx, and we're dividing it by 5 equal to 0. If we're solving this equals 0, then that implies that we can multiply through by 5 to get that 3t squared minus 2t is equal to 0. And so we can factor out a t, factoring out a t, we're left back with 3t minus 2 is equal to 0. And so what you get now is t equal to 0, or what you're getting is t equal to 2 over 3. Bring this over and divide through by 3. You get t equal to 2 over 3. If t is equal to 0, this is x. So you can plug in 0. And when t is 0, you're getting x is 0 plus 3 is 3. So that means we're getting right here, when t is 0, x is 3. And then when t is 0, find the value for y. Let's go back here. When t is 0, y is 2. Y equal 2. Now let's do the same now. When t is 2 over 3, what will be x? When t is 2 over 3, why is it not going back? All right, so when t is 2 over 3, we're going to get x is 5 times 2 over 3 plus 3. And so you get 6 and 1 over 3. So you get 6 and 1 over 3. That's one value that you're getting for x. 6 and 1 over 3. And then you can go ahead and put in y. Put t as 2 over 3 in y. So 2 over 3 in y will give 2 over 3 cubed minus 2 over 3 square plus 2. And so that's 1 and 23 over 27. So y is 1 and 23 over 27. All right, so those are the two stationary points, because dy by dx is a stationary point. So you can conclude, you can tell them that 3, 2, and this other point 6, 1 over 3, comma, 1 and 23 over 27. These are the two stationary points. All right, and tell them these are the two stationary points. Nice. These are the two stationary points. Oh, good. Moving right along. Part C. Part C says y is equal to the square root of 2 plus 2x squared. Show this equation. Now, if you don't know implicit differentiation, go check out the video on implicit differentiation. We're going to be differentiating this implicitly. So now it tells you that y, so you start with y is equal to the square root of 2 plus 2x squared. If y is equal to square root of 2 plus 2x squared, you can square both sides to get that y squared is equal to 2 plus 2x squared. If y squared is equal to 2 plus 2x squared, you then differentiate y squared. When you differentiate y squared, you get 2y times dy by dx and that's equal to, when you differentiate 2, you get 0. When you differentiate 2x squared, you get 4x. That's implicit differentiation, all right? So all you have to do now is bring over the 4x now, and you get 2y dy by dx, 2y dy by dx, 2y dy by dx minus 4x is equal to 0. And if this is equal to 0, if you divide through by 2, so you divide through by 2 now, and you're going to get y dy by dx, y dy by dx, divide 4x by 2, you get minus 2x, and that's equal to 0. All right, nice and easy. So, all right, now the second part says show that d2y by dx squared minus 4 over y cubed is 0. Now, since we have this, I'm going to do implicit differentiation again. Doing implicit differentiation again, it is keep the first times the derivative of the second. Y double prime. Y double prime just means the second derivative. Plus keep the second, which is y prime, times the derivative of the first, which is 1, minus differentiate 2x, now you get 2, and that is equal to 0. Now all I'm going to do now is substituting what is y and y prime. Now I know that y, right here, y is, what is y? Y is this, square root of 2 plus 2x squared square rooted. I'm going to put that in. So y is the square root of 2 plus 2x squared times y double prime two times 2x squared times y double prime plus y prime. Y prime is dy by dx. Looking at it, dy by dx is 4x over 2y. Yeah, man, I don't even need to write out what y is. Write it as y times y prime. Adjust to something. Yeah, man. We don't even need to write out what y is right here. Just keep it as it is. So it's y times y prime and this y prime, which is dy by dx is 4x over 2y. So we're going to put plus. Looking now, if dy by dx, 2 dy by dx is 4x. So what I'm saying, from this part right here, you get that dy by dx or y prime is equal to 4x over 2y. 4x over 2y is 2x over y. All right, that's 2x over y. So we're going to put it here where y prime is 2x over y. And then it have minus 2. So instead of writing minus 2, I'm going to put it, join it, and write minus 2y. And this is equal to 0. I'm then going to divide through by y. If I divide through by y, I am getting y double prime. And you're going to say, sir, I don't see it. I don't see it. And relax, man. Just relax. Divide through by y, you're going to get y double prime plus 2x minus 2y over y squared is equal to 0. Just to check that I differentiated this, right? Keep the first, differentiate the second, plus keep the second, differentiate the first. Oh, made a mistake. Made a mistake. Big apologies. Keep the first, differentiate the second. Different. Keep the first, differentiate the second, plus keep the second, differentiate the first. And differentiate this, I'm going to get dy by dx all square. That was a mistake. So I'm going to get y prime all square. So this should be y prime all square. Made a slight mistake right there. Get y prime all square. So when I substitute for dy by dx, it would have been 2x over y all square minus 2. All square minus 2. Now it's going to simplify and work out. So now, finally, to finish it off, we're getting 4x squared over y squared so getting 4x squared minus y squared minus 2. Instead of writing minus 2, we can put, instead of writing minus 2, we can put minus 2y squared, and this is equal to 0. All right, we're going to need to do some substituting because this needs to work out to be 4 over y cubed. All right, we need it to get 4 over y cubed. So let's see how we're going to generate it now. Now, y squared is 2 plus 2x squared. We have a 4x squared right here. We have a 4x squared. So we have a 4x squared. Let's see how we can generate out some y squared. Plus 2x squared. We want this to cancel down now, because this is not looking too good. Let's see how we can simplify this so that it becomes over y cubed. All of this should work out to be minus 4 over y cubed. So let's see how we'll simplify it. Okay, I just noticed that this should have had the y beside of it as well. This should have the y beside of it. So if you were to divide through by the y, then in the denominator we already have y cubed. So in the denominator, when you divide through by y, this becomes y cubed. the denominator, that becomes y cubed. So we just need to show that this numerator here needs to simplify out to be minus 4. Now let's see how we can show that the numerator simplifies to be minus 4. All right, we know that the numerator should simplify out to be minus 4. Let us see. We know that 2 plus 2x squared is y squared. So substitute for y squared right here. Look at this. If y squared is 2 plus 2x squared, then what we're saying is we have 4x squared minus this part right here is going to become minus 2 times y squared, and y squared is 2 plus 2x squared. This is 2 plus 2x squared. I wish I had space to put it somewhere down there. So 4x squared minus 2y squared. This don't look like minus, so let me fix it up. This is saying 4x squared minus 2 times 2 plus 2x squared, where this 2 plus 2x squared, this part right here is really y squared. So 4x squared minus 2 times 2x squared. As you can see, this becomes 4x minus 2 times 2 is minus 4. Then the 4x squared minus 2 times 2x squared becomes 0. So this part right here works out to be minus 4 in the numerator. So this implies that we get y double prime. That part works out to be minus 4 over y cubed equals 0. So that is shown. Nice. So we show it soft. So just some reference to put right here. Y prime is dy by dx. Y prime is dy by dx. As I said, check out the video on implicit differentiation. Check out the implicit differentiation video. Nice. All right, it says, hence find the value of d2y by dx squared when x equals 0. Find the value of d2y by dx squared. So first thing is, when x is 0, I know that y is root 2. When x is 0, we can see that y is root 2. So let's write it down. When x is 0, we can see that y is root 2. And so since y is root 2, you want to find d2y by dx squared. Why is the root 2 coming out like this? Y is root 2. And so d2y by dx squared, remember y prime prime minus 4 over y cubed. So it's minus 4 over y cubed. And y cubed is just going to be the root of 2 all cubed. This is equal to 0. And so bring it to the other side. And so we're getting that dy by dx, or y double prime, is equal to 4 over root 2 all cubed. If you want to give them the decimal, put it in a calculator. 4 divided by root 2 all cubed. And I'm getting root 2, surprisingly. Root 2. That's second derivative. Root 2. Nice and easy. Soft. Now reach the final question on the paper. The final question on the paper says, PQ and R as vertices 0, 1, 3, 3, and 4, 2, and it says sketch triangle PQR. So 0, 1 mean x is 0 and y is 1. So I can put 1 here. So this would be the point P. Q, so this is the point 0, 1. Q is the point 3, 3. So if this is 0, I can go 1, 2, 3, 4. So this is 3. And so Q is the point 3, 3. So if this is 1, 2, 3. This is the point Q, 3, 3. And then R is the point 4, 2. So this is 4. This is 2. So triangle PQR is this. This is PQR. All right, nice. Now this is triangle PQR. Now it says determine the equations of each of the following. So determine the equation of each. So first we need the line PQ. So first thing we need the gradient of the line PQ. The gradient of the line PQ is equal to rise over run. So it's rise from 1 to 3. So the rise is 2 and it run 3. So the gradient of PQ is 2 over 3. And the equation of the line, so that implies that the equation is given by y is equal to 2 over 3x plus 1. That's the equation of the line PQ. This is the first one. This is the equation of PQ. All right, now let's look at QR. Now the equation of the line QR. So we need the gradient of QR. So the gradient of QR is equal to, gradient of QR is the rise. The rise is 1 over the run of negative 1. So rise, it actually don't rise, it actually go down. So it go down, going down from 3 to 4. So it's minus 1 over the run of 1. So the gradient of QR is minus 1. And so what will be the equation of QR? The equation of QR is then going to be y minus the y value at r. Let's use 2. So it's y minus 2 is equal to negative 1 into x minus 4. Then making y the subject, what we're going to get is y is equal to, that looks like minus x plus 4 minus x plus 4 plus 2. So y is equal to minus x plus 6. That's the equation of, which one was this? QR. This is for QR. This is the equation of QR minus x plus 6. Let me just highlight them. This one is PQ. This one is QR. So we have one more equation to find, and that's the equation of, oh, it had to give us more space, because I was like, that's crazy. Now we need to find the equation of PR. So first thing we need is the gradient of PR, and the gradient of PR is equal to rise over run. The gradient of PR will be the rise of, from here, where's PR? P and this is R. So it rises from 1 to 2. So it rises by 1 and it runs by 4. So that's a quarter. The gradient of PR is a quarter. And so the equation of PR, I know I shouldn't write it down here. Let's write it around here then. The equation of PR is going to be y is equal to a quarter x plus 1. That's the equation of PR. Nice. Now that we get that, I can tell you what they're gonna ask. They're gonna ask to find the area of this triangle using integration. Now, before we even use integration, how do you find the area of this triangle? Now, remember from C-sec math, I just want to show you something, how to find area of triangle. Many of us would not have learned, even ever use this formula, but it's always there on the formula sheet. Area of a triangle is equal to the square root of s into s minus a times s minus b times s minus c. This has always been on the formula sheet. We know you also have a half AB sine theta and all of these formulas, but this is a nice little formula, right? When you have all the sides of a triangle, you can use this to find its area. And I really would like to see people utilize this formula more. So this is S, this is to find the area, where S is A plus B over 2. So let's find the area using regular thing. And then when we use integration, I'll get the same thing we know correct. So the length of PQ, if you were asked to find the length of the line PQ, length of the line PQ would be, it is PQ, it is x2 minus x1 square, which is 3 square, plus 3 minus 1 is 2 square, 3 square plus 2 square is 30. So PQ is the square root of 13. That's PQ. QR is going to be 1 square plus 1 square, plus 3 minus 4, that's minus 1 square, plus 1 square, that's 2 square, that's the square root of 2, that's the length of QR. Length of QR is square root of 2. Since the length of QR is the square root of 2, then what would be the length of RP or PR? PR would be the square root of PR would be 4 square plus 1 square, that is 16, plus 1, that's 17. So PR is the square root of 17. All right. So I'm going to use that to find out the area. Yeah, man. I just like to use formulas that we'd never used before in C-sec. They were just there. So S is going to be equal to the root of 13 plus the root of 17. Root 13 plus the root of 17 plus the root of 2 divided by 2. That is S. So you can put that in a calculator to get what S is. Root 13 plus root 17 plus the root of 2 divided by 2. So you get S is 4.57. So you're going to use that now to find the area. So the area is the square root of 4.57 times S minus A means 4.57 minus, this is now 4.57 minus A. A is the root of 13. So 4.57 minus the root of 13 times 4.57 minus the root of 2, 4.57 minus the root of 2 times 4.57 minus the root of 70. So you put all of this in a calculator, and you might say, sir, why are you doing this? Again, we're going to get the same answer using integration. That's just I want to show. I really like to show these things. So when you work this out, you're going to get, I'm going to put all this in my calculator. Putting everything in my calculator. So I get the square root of 6.25. And so I'm getting that the area is 2.5. So I get that the area is 2.5 or 5 over 2. So that means when I do my integration, if I don't get 5 over 2, I know I did something wrong. It's 5 over 2 is the area. So let's do it with integration now. You say, oh, math's nice, man, maths are nice. Let's do it with integration. Using integration, it's going to be the integral from 0 to 3 of the line PQ plus the integral from 3 to 4 of the line QR minus the integral from 0 to 4 of the line PR. That's the area using integration. So using integration, we're going to get that the area is equal to the integral from 0 to 3 of the line PQ, and PQ is 2 over 3x plus 1, 0 to 3 of 2 over 3x plus 1. And I won't put on the dx because of space, but don't ever follow me and do that. Plus the integral from 3 to 4 of QR, and the equation of QR was minus x plus 6. Then minus the integral from 0 to 4 of PR, and the equation of the line PR was, where was PR? PR is a quarter x plus 1. Is a quarter x plus 1. Nice and easy. So let's go ahead and find this integral. So finding this integral now. All right. So we go ahead and integrate. So what we get is, when we integrate, we add 1 to the power 3, divide by the power, so that will become 2 over, add 1 to the power, divide by the power, so that becomes, let me see, x squared times, 2 over 3 times 2. 2 over 3 times 2. Add 1 to the power, divide by the power. So that becomes 2 over 3 times 2. 3 times 2 is 6. And 2 over 6 is just 1 over 3. That becomes 1 over 3x squared plus x. And that is being integrated from 0 to 3. Plus, this part becomes minus x squared plus 6x. And this part is being integrated from 3 to 4. And then finally we have minus Add 1 to the power x squared divided by the power. So it's 1 over 4 times 2. 4 times 2 is 8. So it's minus, that's x squared over 8. I'm going to make sure, plus x. Yeah, man. And this one is going from 0 to 4. So now we may go ahead and plug in 3. So plugging in 3, we're going to get 1 over 3 times 3 squared plus 3. So when you plug in 3, you're going to get 1 over 3 times 3 squared plus 3. So I get 6 right here. Now plug in 3, I get 6. Don't need to plug in 0. Plus, when I plug in 4 in here, I get minus 4 squared plus 6 times 4, which is 8. So I get 8 minus, I plug in 3, I get minus 3 squared plus 6 times 3. So I get 8 minus 9. Close up that. Minus, don't need to plug in 0, so I just plug in 4. I get 4 squared divided by 8 plus 1. 4 squared divided by 8 plus 1, which is 3. So what I'm getting is 6 plus 8 minus 9 minus 3. I'm getting the area as 2. So this gives me the area is 2 units square. 2 units square. But when I use the formula, I was getting 2.5. Formula was giving me 2.5. Why was that? Let's check back and see if I made any error here. That's why I like to do it both ways. I can just definitely tell if I'm correct. The root of 15 plus the root of 17 plus the root of 2 divided by 2, that's 4 point. Root of 13 plus the root of 17 plus the root of 2 divided by 2, that's 4.57. So 4.57 times 4.57 minus the square root of 13 times 4.57 minus the square root of 2 times 4.57 minus the square root of 17. I'm getting 2.5. I don't understand. 2.5 is correct. That's the area. So let me check again. Add 1 to the power x squared. Divide by the power. It's 1 over 3. Add 1 to the power. So when I plug in 3, 3 squared is 9. 9 over 3 is 3. 3 plus 3 is 6. Minus x. Oh, shoot. You see why it's good to do it both ways? Add 1 to the power, divide by the power. So I knew I made a mistake. I like to do it both ways to check my answer. It validates both my answer. So in here now it's going to be 8 over 2, which is 4. So now I need to change up this. This part is not going to be the same as in here. So when I plug in the 4, I'm going to get 16 over 2, that's 4 squared divided by 2, that's minus 8, plus 6 times 4, that's now positive 16. And then I put in the 3, I get minus 3 squared Divide by 2 plus 6 times 3. That's 13.5. So I get minus 13.5. All right, nice. And here when I plug in the 4, I would have gotten 16. 4 squared 16. 16 over 8 is 2. 2 plus 4 is 6. So even this part wasn't right. This was 6. Oh gosh, so much calculation mistake. And now when I work this out, I'm going to get 2.5. So I made some mistake there. And as you can see, it was very imperative that when I do it the other way, when I found the area the other way, it made sure I got it right. I know what you're saying. You're saying, sir, we might not have so much time in the test, but yes, you do. All right, do a rough sketch of your triangle and you can do this real quickly, 5 minutes. If I can talk and explain it and still finish on time, you have enough time to do it. Now, this is a differential equations question. It says the voltage in a circuit satisfies this equation. Given that V is 25 when T is 0, write an expression for V in terms of T. So first thing, dV by dt is equal to, I can bring over this part over here to have minus V over 2.5. Now minus V over 2.5, I can rewrite that as minus 1 over 2.5 minus 1 over 2.5, which is minus 2 over 5. This part becomes minus 2 over 5 times V, and that is dV dt. Now I need the V's on one side, so I'm going to multiply across dt and divide out V to get 1 over V dV. 1 over V dV is equal to minus 2 over 5 times T. All right, dt. Not T, dt, not T, dt. Minus 2 over 5 dt. Minus 2 over 5 dt. Okay. Now once I get that, what I need to do is integrate both sides. So I integrate both sides. When I integrate both sides, what I get is the integral of 1 over V. That's going to give me ln V. When I integrate this side, I will get, integrate this side, I get minus 2 over 5, I'm going to write as 0.4. That's minus 0.4 T plus some constant K. So now, if ln V is this, I'm going to raise it to exponential E. So I'm going to raise both sides to exponential E. And then E to the ln cancel. And so V is equal to E to the minus 0.4 T times E to the K. But look at this, it said when T equals 0, V is 25 when T is 0. So that implies that when T equals 0, we're going to get that V is equal to this part. When T is 0, you get E to the K, and so E to the K must equal 25. And so 25 E to the minus 0.4 T. (25 e to the minus 0.4 T), that is V. All right, nice and easy, soft. All right, Now we reach this part of the paper now. It says, given that the integral from -1 to 3 of 3f of x plus g of x equals 5, and the integral from -1 to 3 of 5f of x minus 2g of x is 1, determine these two. Now, looking at the first part of the question, given this, I'm going to break it up. We can always break up this part as 3 times the integral from -1 to 3 of f of x plus g of x plus the integral. We're going to break it up now as the integral from -1 to 3 of g of x. I left off the dx, I know. This is equal to 5. Now look what I'm going to do. I'm going to call this part a, call this integral a for now, and call this integral b. So what they're really telling us from this is that 3a plus b is equal to 5. So clearly, that means the second equation is going to be 5a minus 2b. The second equation is going to be 5a minus 2b is equal to 1. All right, so you can just solve this simultaneously. So multiply the first equation by 2 to get this one multiplied by 2 will become 6a plus 2b. I'm going to multiply it by 2. I'm going to change this to 6a now plus 2b equal 10. The 6a plus 2b equal 10. Then I can add both equations. And so 6a plus 5a is 11a. And so 11a is equal to 11. And so a equal 1. If a is equal to 1, then therefore that means they're telling us that the integral from -1 to 3 of f of x is equal to 1, because that's what we call a. So that is equal to 1. Since we get that out of the way now, what we're going to do now is we're going to find out what is b. To find out what is b now, we plug in the simultaneous equation, we find a, so 5a, that means that 5 times 1, which is 5, minus 2b equal 1. So that means 4 is equal to 2b, and if 4 is equal to 2b, then therefore b equal 2. Therefore b equal 2. And if b is equal to 2, then that means that the integral, so therefore the integral of g of x is equal to 2. And this is integral from -1 to 3. Nice and easy, soft. So this is equal to a, and a is 1. And this is equal to 2. That's the answer. Those are the answers. Nice and easy, soft. 1 and 2. Nice. And it finished. This paper finished. So we've come to an end of this paper. It was so easy. I hope we had fun, like how I had fun. And I wish you all the best prepping for your exam. Soft.